Hello my dear students, how are you? I guess all of you are doing well. Remember last video that what we discussed? We discussed about factorials. Factorials, what were they? And of course if you remember last video I also told you the importance of this particular chapter. Certain things are removed with the new syllabus, revised syllabus especially for this year. I'm just going to ignore that, especially with this chapter. We will be doing everything, okay, because this chapter is just so important. I already talked about the importance. The why is it so important and why is it so much used in competitive examinations and all this, because it can just play with your mind, okay, just there's no specific formula, no such that, so it can just play with your mind. And yes, that's why I guess that's the reason why many students say that this chapter is like very difficult. I would rather not say difficult, okay, it's just because you need imagination also. Imagination, see how are we in counting? It's not about this counting, no 1, 2, 3, 4. No, it's not about the counting that we're going to be discussing. No 1, 2, 3. No, that's not the count. It's about the imaginative counting. We know it's simple counting, but we just cannot hold it. No, we just have to imagine all the combinations, all the arrangements. So there can be so many questions based on that, and that's why I guess. But actually the trick lies in the mantra. Mathematics is always about the more you practice, the better you become. There is no other better short trick other than that. No, practice. But yes, if you can just understand the theme, then actually all these formulas are not going to be required also. But yes, we also have to know. Now what I've written here is like fundamental principles of counting. One is the multiplication principle, the other one is the addition principle. So I'll just step aside for the time being. Maybe I'll step aside here. You can pause the video if you wish, and then you can write it down, because I'm just going to rub this very quickly. Because see, this is one, not a theorem, but you don't have to memorize this formula. Okay, you don't have to memorize this formula. Absolutely not. This is just a concept, principle which without which also we can do. Just it's not that you really have to use it, okay, without which also we can do. But anyway, let's just go through it. Like, if an event can occur in m different ways, I'll discuss about that. M different ways following which another event can occur in n different ways again, then the total number of occurrence of the events in the given order, don't forget that given order, is m into n. That's why it's called multiplication principle. Other one is if an event can occur in m different ways and another one can occur in n different ways, then either of the two events can occur. Either of the two events can occur in m plus n ways, provided only one event can occur at a time. Either means or. Here, then the total number of occurrence of the events in the given order, that means m occurring, after that n occurring, m happening, after that n happening. That means both of them are happening, both of them should happen. That's why it's called that's why it's called the multiplication principle. That is the difference, okay. Here you have an option, either this or that. Here, no, this and that, this and that. This one, either this or that, either this or that. So that's where we use this addition principle, multiplication principle. I bet you have all understood, definitely, isn't it? No chance, it's not that simple, I guess. But don't worry, I have a very good example which will actually clear most of the doubts. Okay, but as I was telling you, this is not a formula that which we have to remember, okay, without which also we can do. But let's just try to understand what this fundamental principles of counting, of multiplication and addition, actually what are they trying to tell us. Alright, but before that, always do remember, see, these are simple concepts which you should also understand. Like, that's why I was telling you, you have to feel that question. You have to feel that question. Imagination just holds the key to mathematics. You have to feel the question, understand the question, visualize the question as if you're already there, as if you're present there. Because from there only you will know like whether the condition is about like both this and that should happen, or the condition is like either this or that can happen, no, either or. But there are terms see, always remember, and will always mean multiplication, especially in this case. Either or, and especially or will always represent addition in this case. Okay, just a small tip to remember. So when it's about or, either this or that, it's about addition principle, so to say. And means this and that can happen, should happen, first event and then second happen, and then the second event should happen, multiplication. Alright, so okay, that might just help you a little bit. Okay, but again, as I repeat, all these theorems, principles and all, yeah, we need the concept, but we need more of your common sense. Okay, and I think and I believe that really works for all of us. Now let's take one example and see how we can just work our way through these principles of counting. As I say, these are not going to be simple countings. One, do not counting your fingers. Imagination. Now let's say you start a journey from Dimapur. Let's say you start a journey from Dimapur, then you go to Guwahati. Okay, you go to Guwahati. Guwahati. Don't mind me, pardon me if the spellings are wrong. So from Dimapur to Guwahati, you want to move. Okay, you want to go from Dimapur to Guwahati. So let's say that you have three options. That is, one is by, let's say, bus, the other one by train, and the other one by aeroplane, air. Okay, there can be many more ways. I'm just talking of three general ways. Okay, we can hire a taxi and all, but let's not talk about those. So to go from Dimapur to Guwahati, we have three ways. So in how many ways can you travel to Guwahati? In how many ways can you, listen to the question, because you see the concept of counting, addition, principle, multiplication is actually, according to me, we see all these topics, we all have our different concept, different way of looking at it. It's not that when I explain a certain thing, that's it. No, there will be other people also, other teachers, very good teachers also, who will also have a different approach to a particular problem. So they will also explain it to you in the same way, in a different way actually. But the only thing that's going to be same with all of our the explanation is that the concept will be same, the theme is going to be same. Okay, so this is how I look at it, how I look at my problems. So for me, generally, I would not rather emphasize too much on the theorems and formulas and all. I like to do things in my own ways. It helps me, of course. Okay, so understanding and feeling the problem again, right? So in how many ways can you reach Guwahati? We can go to Guwahati in actually three ways. That's either by bus, or by train, or by air. Or, see, that's how we have to analyze that question. Fine. Then this is one event. Let's say E1. These are called events, no? That's the way I can travel, so that's something about to happen. So these are called events. Guwahati to Dimapur to Guwahati. But so this is that first event, which can happen in three ways. M. So if you remember that, I hope you have written down that multiplication principle. So if an event can happen in M different ways, then another event, a second event, that's from Dimapur to Guwahati, and from Guwahati I would like to go to Kohima. Now let's say that from Guwahati to come to Kohima, I have, let's say, two ways. That's, let's say, by bus or by private taxi, direct. So from Guwahati to Kohima, how many ways do I have? So this is my second event, okay, E2. So I have actually here how many ways? Two ways, isn't it? Now let's see the different kinds of arrangements. In how many ways can I reach from Dimapur? Now Guwahati, forget about that. From Dimapur to Kohima, in how many ways can I reach? Let's find out. Let's see how many kinds of combinations, how many kinds of arrangements can we make. Okay, and we will be verifying the multiplication principle, as well as we will be seeing the application of addition principle also. Now let's see. From Dimapur I start. So bus first combination, right? Bus and then bus, right? From Dimapur to Guwahati bus, and from Guwahati I take the bus to Kohima. Another combination arrangement that I can have is from Dimapur to Guwahati I go by bus, and from Guwahati I go by taxi. So I go by bus, and then taxi. This is one combination. Then another combination, I'll just write here, it's okay, right? Another combination that is, let's say, train. I go by train. I reach Guwahati. From Guwahati I go by bus. Another combination, I go by train again. Then I take a taxi. So that's like, here we have like two ways, here we have like two ways. These are the combinations. Now, then another one, that is from Dimapur I travel by air. Then I take a bus to Kohima. Or I travel by air and I take a taxi to Kohima. So how many combinations, in how many ways can I reach Kohima? That's like two. Either I take a train, then a bus, or a taxi, or either, or. So all this comes into play, no? Either, or. Either I travel by air. If I travel by air, then I take a bus or a taxi. I travel by bus, then I take either a bus or a taxi. So it can happen in how many ways? 2 plus 2 plus 2. Because see, all of it, at a time I cannot travel in all the ways. No, I have to just take one route. Bus, bus. Or bus, taxi. Or train, bus. Or train, taxi. Or air, bus, air, taxi. So in or, I hope you're getting a feel of that. Now, when can we use this addition, right? So it can happen in how many ways? 2 plus 2 plus 2. So the total number of the total number of ways to reach Kohima, I have how many ways? I have 6 ways, isn't it? All right, let's keep that in mind. Now, what multiplication principle tells us is exactly about that. To find out the number of ways directly, not using all these combinations, because if we have big combinations, then it will take a lot of time, no, to connect all of that. So just to avoid that, multiplication principle simply tells us, see, that's why this events. First, I have to go from Dimapur to Guwahati compulsorily. That's my event. After coming from Dimapur to Guwahati, after that, the second event happens, Guwahati to Kohima. That's what the multiplication principle states, that if an event can occur in m different ways, following which another event occurs in n different ways, then the total number of ways of occurrence of the event is m into n ways. That is how many ways? 6 ways. So that is what multiplication theorem states us. But in this process, we also got a feel of the addition theorem also, where we talk about either or. It's not compulsory. I can either travel by this or that. So see, there will be like combination questions, because there will be questions where you will be using the multiplication principle also and the addition principle also. So that's what I was telling you. These principles are just like simple concepts which we need to know. That's okay. That's a multiplication principle, addition principle. But no, we're not supposed to memorize that, because every question is going to be different. It's all about how you feel and imagine the question. You can also express that in your own words. Maybe you can just write a full page for the solution also. So we are going to be solving exercises. So it doesn't mean that you'll have to do it the exact way. You can just express that particular problem in an examination in your own way. So that's why these questions are actually like so practical. Okay, so practical that it's interesting. You can write in your own ways, in your own way of understanding also. No fixed actually formulas for that. No, I don't prefer that. And this actually, here we have just mentioned 2 events, m and n events. this actually can be extended to a more number of events also. Okay, this multiplication and addition principle can be extended to more number of events also. Here we had only 2 events, it can be extended to 3 events also. I'll tell you another example, that is, so this was my event, let's say E1. And this was my event E2. Now let's elaborate the story a little bit more. So from Dimapur I go to Guwahati, from Guwahati I go to Kohima, and from Kohima, after reaching Kohima, I have to get home. So I can get home in, let's say, home. So I can get home in maybe, let's say, another 2 more ways. Let's say either I hire a taxi or I walk. Okay, either I hire a taxi or I walk. So now how many events do we have here? Dimapur to Guwahati, 1 event, Guwahati to Kohima, another event, Kohima to back home, that's another event. So we have actually how many events here? 3 events. So if I can just quickly work out, that is, what can be my possible either, or. So if I travel by bus, then bus, taxi, or bus, Guwahati from, right, so bus, I take bus from Dimapur to Guwahati, then I take taxi, right? Or there's another combination here also, bus, from Dimapur I travel by bus, reach Guwahati, I take a bus, right, and then I walk. Another combination, bus, then next is taxi. So with taxi also I have 2 more combinations. I take another taxi again or I walk. You got that, no? From Dimapur I take a bus. After reaching Guwahati I take a bus. After reaching Kohima I decide to take a taxi or I decide to walk. This one is from Dimapur I take a bus again. After reaching Guwahati, this time instead of taking a bus I take a taxi. And after reaching Kohima, either I take a taxi or I again walk. So these are all the combinations. So how many ways in which this can happen? Like 1, this is 1 way, this is 2, this is 3, this is 4 ways, isn't it? This is another 4 ways. Right, so in that case, okay, let's increase this 1 more. Let's say maybe I can take another one. That's again, anyway, let's just not increase that too much. So likewise, if you go for the number of combinations, how many are we supposed to get exactly? But see, that's why the more it becomes, the more the events become, what happens is the more complicated it becomes, the bigger the problem becomes. So because the next option will be train. And train, if I just, so here how many ways? 1, 2, 3, 4. 4 ways. Let's say 4 ways. Then, if I travel by train, then of course the same, train, bus, taxi or walk. Train, bus, taxi or walk. Then train, taxi, walk. So that's another 4 ways. Then again, if I travel by air, bus, taxi, walk. Air, bus, taxi, walk. Air, taxi, walk. So that's another 4 ways. So that's again with 4. Then I can travel in actually, like I have 12 different options. What if I had 4 options here? Then that's really going to be quite messy. Now we don't have all the time in the world just to solve one problem and then keep on doing that. And once we understand that question, we can easily apply what? Multiplication theorem, because we have seen that these are of 3 events, E1, and then E2, then E3. So these are all simultaneously happening in a particular order. It's not that either these can happen or that can happen or that can happen. No, all this should happen. From Dimapur you have to go to Guwahati, from Guwahati you have to go to Kohima, and from Kohima you have to reach home, and it should happen. So in that case we can just use 3 into 2 into 2. So 2 2s are 4, 4 3s are 12 ways, and that's how we use multiplication principle. Okay, so I have got I hope that you've got a feel about this multiplication principle and even this addition principle also. Now, but I know that this is not going to be enough. Okay, definitely not. This is not going to be enough. Don't assume that, see, you will just understand everything from a simple lecture from any teacher and all. No, that's not how it works. Okay, that's not how it works. Okay, I help you in my own ways to the best of I can, but that's not going to be enough. You watch another video also, no, that's also not going to be enough. Only when we jump into the problem, then we start solving the problem, that's how you start learning. And actually I would suggest, this is my suggestion, like I would actually suggest you to try all the problems on your own first. Okay, you can try to look at some of the videos that your teachers are providing, try to analyze, understand, and then okay, you try the problems on your own first. Don't worry even if it's not possible in the beginning, 1-2 attempts, but you should try. Okay, that's what I would always tell you. You should try, because you have to imagine, okay, you have to feel that question, you have to imagine that question and try. And please don't move forward until unless that first question is done. Okay, sometimes what happens is you do first question, then what happens is you can't do it. Okay, you skip to the next question or just get the solution from the videos. No, don't do that. Try. Only when you just give up, okay, that time you can just watch the solution. That will just help you. Okay, that will just make every point very, very clear. All right. Now that is what is fundamentals of principle, and we can just do one example based on that. Okay, you can just write one question. We can just do one very quick example on that. That will be like how many, if you understand the question, it is very, very simple. How many 3-digit numbers? Of course, we have permutations and combinations also. How many 3-digit numbers? But actually, most of the questions, actually I would say 50% of the questions can be simply solved by this concept of fundamentals, principles of counting. Okay, 50%, definitely more than that actually, formed without using the digits. Without using the digits. 0, 2, 3, 0, 2, 3, 4, 5, 6. 0, 2, 3, 4, 5, 6. Okay. What is the question here quickly? How many 3-digit numbers can be formed? We all know what is a 3-digit number. We can use a block experiment for that, block explanation for that. 3-digit. So that's units, tens, hundreds digit. We all know that. Let's not elaborate on that. So you have to form a 3-digit number. What are the conditions? Let's see. How many 3-digit numbers can be formed without using the digits 0, 2, 3. How many digits do we have, by the way? 10 digits, 0 to 9, isn't it? But we're not supposed to use this digit. So what are the digits left with us? 1, right, 2, 3, 4, 5, 6, 7, 8, 9. So we are actually left with only 4 digits which we can use to form our 3-digit number. How many 3-digit numbers can be formed without using the digits? How many 3 digits? So there's nothing mentioned about you can repeat the digits, you cannot repeat the digits. So we will assume definitely that we can just repeat the same digits also. That means I can even have 1, 1, 1 also, no problem, because they're not telling that you cannot repeat, no problem. Then but at hand we have only 4 digits with us. So here in how many ways can we fill up this units place? I can either fill it up by 1, 7, 8, 9. Similarly, tens place also I can fill it up with 1, 7, 8, 9, because see, I can repeat the digits also, not a big problem. Similarly, hundreds place also I can fill it up with 1, 7, 8, 9. So that means each each place I can fill it up with 4 ways, 4 ways, 4 ways. And so that's how I can fill it up. But so that means here I have 4 ways, here I have 4 ways to fill up either this or this. So 1 plus 1 plus 1 plus 1, that's 4 ways, isn't it? So similarly, but the condition is, see, I have to get this 3-digit number. That means it's not that I should write either hundreds place or tens place or units place. No, I have to get a 3-digit number. That is, I have to get this hundreds digit and the tens digit and the units digit. 3-digit number, so it's compulsory, hundreds, units. So you can start with units place, tens place, hundreds place also, no problem, because we have to maintain that specific order. But not in this, it's not necessary, because sometimes last digit should be an even number. There are many conditions, we'll be doing many questions on that, but here it's okay, no problem with that. So maybe I just start with units place. So I have, after I do my find out the arrangement for my units place done, and I'll go to the tens place and I'll go to the hundreds place. So in that case, in how many ways can I fill it? Can this 3-digit number be formed? That's going to be 4 into 4 into 4. So 4 4s are 16, 16 4s are 64. So I can use 64 arrangements. Okay, this I can form this 3-digit number in 64 ways using these letters, digits 1, 7, 8 and 9. So that's why actually we did not use any particular formula here, did we? No. So that's why most of the question just actually depends on our understanding of that question only. That's what we are going to be doing. Alright. Okay, so fine then. I hope I'll just leave you there for today. That's like fundamental principles. I know that a lot has been confused, but don't worry. We'll be solving exercises and extra questions also definitely in the next video. So that will definitely help you a lot. And as I say, solve as many questions as you can, so that you will be gaining more and more experience. Alright, so fine then. I'll see you in the next video with the solution of the first exercise 7.1 and extra questions also. So bye bye, till then, see you very soon.